Hello everyone, I'm Yu Yang. I'm from China. I work in VMWare. Today I will introduce GreenPlan to you. GreenPlan is an open source database. In Gartner's reports, it's the first open source database in the ranking, compared with the Teradata and Oracle. Let's start to introduce GreenPlan architecture. GreenPlan is composed of many Postgres nodes. With one node we call master, and other nodes we call as segment nodes. The data are stored in segment nodes instead of master. Master merges segment data. When query comes, master nodes first make the plan and then convert SQL statement to plan. Then it dispatches the plan to every segment node. Each segment node has its part of the plan of the whole node. Then start to do the real work. For example, the segment node will do the segment scan, hash join, or aggregation. After all segment nodes finish the work, master nodes will gather the results from segment nodes and return them to the client. So this is the whole process of a life cycle. It's a distributed share nothing architecture. Components work independently and no components is shared between each independent components. It's a linear scalability. It can scale from 100 gigabytes to over 100 petabytes of data without any performance penalty. GreenPlan can process many types of data. The first type is structured data, which is stored in the table. The second type is semi-structured data, including JSON, XML, and etc. The third type is unstructured data, including Word, PDF, and etc. GreenPlan has an extension called GPText. It can retrieve data and index data from rich documents, which is stored in the PDF Word. For data location, data could be local or stored in cloud storage like S3. GreenPlan also can process the data stored in SDFS. GreenPlan provides many kinds of analytics. First, GreenPlan can work with traditional analytics. It could work with business intelligence very closely and smoothly to produce the reports. Second, GreenPlan provides advanced analytics, include geospatial, graph, text, regression algorithms, classification algorithms, and clustering algorithms. MyLib is another project, provides in database analytics in GreenPlan. It's an open source upper top-level project with a joint effort between GreenPlan engineering team and other teams like the Berkeley University. It provides wide range of machine learning algorithms, including supervised learnings, unsupervised learnings, nearest neighbors, graph sampling, time series analysis, statistics, data types and transformations, and the model selections, and so on. User could use the SQL interface to do machine learning in GreenPlan. GreenPlan also supports spatials. It has an extension called PostGIS. PostGIS supports spatial project types, functions such as points, lines, polygons, area, intersections, contains, distance, and so on. And in addition, PostGIS supports raster. Text data also could be processed efficiently by GreenPlan. GreenPlan has an extension called GPTest. GPTest provides SQL interface and integrate text functions with structured data analytics. With Matplotlib and the GPTest work together, GreenPlan provides machine learning on text data. In addition, we could use procedure language for natural language processing. GreenPlan also provides the processing language. User could use their own familiar language like the Python, R, Perl, Java to write logics to process data in GreenPlan database. And also PR containers help isolate and customize processing in containers for PR languages. We can use processing language to easily parallelize any standalone library in Java, Python, R, PGSQL, or C++. The interpreter and the virtual machines of language X is stored on each node of the MPP environment. GreenPlan can deploy any workloads on any infrastructures. For example, GreenPlan can run in the bare metal in the local machine style. In addition, GreenPlan can run in the private cloud, such as VMware, vSphere, and OpenStack. In addition, GreenPlan can run in public cloud, such as Amazon Web Services, Google Cloud Platform, and Microsoft Azure. GreenPlan also can run in the container environment. For example, Kubernetes. Also, GreenPlan can provide running the building blocks. In summary, GreenPlan is a modernized data analytics platform. In bottom layer, it is the massively parallel analytics engine running in vSphere, OpenStack, and the cloud environment. In middle layer, GreenPlan can process multi-structured data and enhance the security. In the top layer, GreenPlan provides advanced analytics, spatial, and text processing. In summary, GreenPlan can run anywhere, any deployment, process any data, and provides any analytics. Next, I will share some use case for GreenPlan. The first is the large-scale fleet management. For many large organizations with fleet of vehicles, fleet management practices have remained largely unchanged for more than 20 years old. That is a disadvantage is following. It's a manual process, use siloed data, and its rule-based approach for decision-making, no machine learning, and no optimization. So there are many opportunities to gain significant cost saving. For modern vehicle instruments, there are many sensors. For example, front camera, rear camera, temperature sensors, GPS sensors, fuel sensors, and panic buttons, driver behaviors, messages. So there are many sensors. For each hour, there are more than 25 gigabytes data produced. For each year, there are 380 terabytes data produced. So they have a lot of data to process. GreenPong is good at process lot of data. So we could send the sensor data to Kafka. Kafka is a stream engine. It can ingest in the sensor data and push the data to the GreenPong engine. GreenPong can ingest the data inside, and we could use the MATLAB, linear the machine learning library in database analytics and other processing languages to process the data, and also provide a REST of API to serving. Use this data, we could provide the many predictions. For example, vehicle end of life prediction based on the usage, maintenance, and repair data. The data stored is in a secure, scalable, and integrated analytics environment. Another case is the SIMPAC predictive maintenance. For SIMPAC, there are many data stored in the logs. For example, in the timeline, on Monday, motor unride is vacant, but low one is available. On Tuesday, motors start to fill, but not enough to trigger ride stop. On Thursday, ride stopped due to fault. Team repairs motor. Ride restarted. This is log data. We could load this log data into GreenPong for analysis. GreenPong could use MATLAB or processing language and to do the machine learning on the data and then the predictive model. For example, on Monday, motor unride is vacant and the data is being collected. On Tuesday, data from previous day suggests the motor problem and trigger a plan. After park close, team start to investigate, find and repairs vacant motor. On Thursday, guests enjoy ride all day. Low rate failure happens. So we could use this historic data, do some machine learning, and provide the predictive model. So there are a lot of use cases to share, but due to the time limitation, we just share the two cases with you guys. That's all. In the last, I will mention that there will be an GreenPong meetup in Xi'an on June 25th. So if you guys are interested in this event, please let us know, scan the code, and join us. Please join the WeChat group to get more information soon. Okay, that's all. Thank you. Bye-bye.